Okay, we are going to talk about surface area and volume and lateral area of cones today. So remember, a cone has a circular base and it comes to a point. So when you unravel that, you have this circular base here, and then the actual cone part, the pointy part of the cone, the lateral area it's actually a sector of a circle. So it looks something like that. And that's going to help us with the formula here in just a minute. So the number of bases in a cylinder, this is supposed to say cone. Whoops, my bad. Number of bases in a cone is 1, and the shape of the base is a circle. And the shape of the lateral net of a cone is a sector. It is a piece of a circle. Okay, so we're going to use that to come up with the formulas for lateral area, surface area, and volume. So for starters, we have our base, and the base is going to have a radius. Okay, so the area of this base is just pi r squared. All right, so that's easy for the area of the base. The base is equal to pi r squared. Now the lateral area is equal to, well, this length of the sector, it is actually the circumference of the base, right? Because we unravel it from the base and it fits around the base perfectly. So we know that is, circumference is 2 pi r. And then this dimension right here, well, that's the slant height, right? Down the side of the cone is the slant height here. So we're going to multiply it by L, and then basically what you do is you break this up into like little triangular sectors, and you add them all up and use the whole circumference. So to find this area, we're going to multiply this by a half. Well, a half of 2 is just 1. So the lateral area is equal to pi r L. So the lateral area is equal to pi r L, and the total surface area is pi r squared plus pi r L. And then volume, of course, we're going to take the area of our base, right? And we are going to multiply it by the height. There's my purple that I liked so much yesterday. All right, so for volume, we're going to take the area of the base, multiply it by the height, and because this comes to a point, we divide it by 3 or multiply it by 1/3. So there are your 3 formulas. You can use them for every single cone. It's not like a pyramid where your base has to be regular. It is a circle. I don't know what that word was. A circle. So there is no such thing as a regular circle. Circles, it doesn't have angles. So yeah, anyway, we're just going to stop there. All right, let's take a look at some examples. So find the exact lateral area, surface area, and volume of the cylinders. So we're going to start with lateral area, which is pi times r times L. And we're doing exact, so we'll leave it in terms of pi. So our lateral area is pi times our radius is 12. One thing you do want to be careful of is that they're giving a radius versus a diameter. You might have to divide your diameter in half times the slant height, which is given, so that's 26.8. All right, so 12 times 26.8 is 321.6, and I wanted exact, so times pi, and we are in centimeters, so square centimeters. Now, for the area of our total surface area, we need to add in that base. There's only one base, so we're going to add in a pi r squared, and r is 12, and we need to add that to that lateral area. And so that's 144 pi plus 321.6 more pi So that is a total of 465.6 pies. It's a lot of pies. And that's square centimeters. All right. So there's our total surface area. And we found our lateral area. So now we need to find the volume. So the volume is 1/3 of the area of the base, which we figured out was 144 pi from the surface area, times the height of our solid. Now, here's where we have to do some work again. We have the radius. We do not have the height. The height is missing, right? But we do have the slant height. And so if you can imagine, the height goes down to the middle of the cone. It connects with a radius, and then that connects to the slant height. So we can use this right triangle and solve for h using the Pythagorean theorem. So that's not too bad. Got 12 here and 26.8. And we're going to solve for h. So h squared plus 12 squared equals 26.8 squared. Let's see here, 26.8 minus 144. So h squared. Hello, pen. Where are we? Equals 574.24. And if we take the square root of that, we get 23.96. So we're going to round that to 24.0. Okay, so we can pop that in our formula times our height, and we get, well, 1/3 of 24 is 8 times 144 is 1,152 pi cubic centimeters. That was volume, excuse me, a third dimension. All right, so there you have it, an example for finding the surface area, lateral area, and volume of a cone. It doesn't really get more complicated than that. You're just going to use Pythagorean theorem. So if you think you've got it, go ahead. Or you could do number 5 and then fast forward to the end of the video and check your work. All right, so number 5. Let's see here. And number 6. So I'm actually going to pause the video and put all of my work up for number 5, and then I'll work through number 6 with you. So you should do the same. Okay, so I worked out number 5. I will say the one thing, we needed to find the slant height. That wasn't given, so I used the Pythagorean theorem, and I found that the slant height was 4√10. Now remember, our instructions said exact, so I'm going to leave it in terms of a radical form to keep it exact. So that 4√10 goes in for L wherever I have L. So my total lateral area, I believe, is 16 pi times √10 square miles. My total surface area, I needed to add the base to that. The area of the base was 16 pi square miles. So that doesn't combine with 16 pi √10. So it's just 16 pi plus 16 pi √10. And my volume was 64 pi cubic miles. All right, let's take a look at number 6, and then that will wrap up today's lesson. So our lateral area is pi times the radius times the slant height. And we are given the slant height, but we are also given a diameter instead of a radius. So our radius is 10. It needs to be divided in half. And our slant height is 22.4. My pen is struggling tonight. All right, so our slant height is pi times the radius times the slant height. And if we're leaving that exact, 10 times 22.4 is 224 times pi. So that's 224 pi square inches. And our total surface area, we need to add the area of the base. So our surface area is the area of the base, which is pi r squared. So that's pi times 10 squared, which is 100 pi, plus our lateral area. And so we get 100 pi plus 224 pi's, and that's 324 pi's. And we're in square inches. And then finally we need to do our volume, which is 1/3 times the area of the base. Sorry, that's 100 pi. Times the height. And here's where we have to do a little bit of work. We don't have our height. So again, we're going to use Pythagorean theorem. Our height is here. Our radius is 10. And we need to use a slant height of 22.4. So we're going to do h squared plus 10 squared equals 22.4 squared. And we're going to get, let's see here, about a little bit over 20. 20.04, so we're just going to go with 20.0. All right, so the volume is 1/3 times 100 pi times 20, and let's see, that is 666.6 repeating. Ooh, that's a lot of sixes. All right, 666 2/3 pi time, let's see here, cubic inches. All right, and really that's written, it's a little nicer if you put that as an incomplete or an improper fraction. So we could say 2,000 pi over 3 inches cubed. Whoops, getting carried away. All right, there it is. Have a great weekend. Next week we will talk about spheres and hemispheres, and then review on Tuesday, and I think, don't hold me to it quite yet, but we're looking at probably a 2-day test on Wednesday and Thursday. Have a great weekend. I'll talk to you later. Bye.